For my experiment, I chose to observe the motion of a miniature Coke can on the rim of my floor. I chose this object and location in hopes that it would have very few external forces acting on it, such as friction or gravity. In this first clip, we can see the original video of the can rolling. In this next clip, we can see Tracker's motion analysis of the previous video. Using Tracker, I was able to construct a position versus time graph by tracking the center of the Coke can frame by frame. As you can see, this position versus time graph has a negative slope as I set my tracker axis origin to be just to the right side of the Coke can when it entered the frame, meaning it would register a negative velocity as it moved throughout the video. Since the motion of my object was from left to right, my velocity was always going to be negative. However, this gave me much easier starting values. I was very pleased with the motion versus time graph I was able to derive from the tracker application. The slope on the position versus time graph looks relatively constant, which means that the velocity of the Coke can remain fairly constant throughout the video. This next image is a recording of my GlowScript model output. As seen in the video, the ball, which represents the Coke can, moves in the negative x direction at a constant velocity. Some important assumptions made in this GlowScript model were the initial position of the Coke can and the average velocity, which was calculated by taking the final position of the can that was found in Tracker and subtracting it from its initial position, which was also found in Tracker, and dividing that by the total time that elapsed between the initial and final position, which was as well found in Tracker. One more important assumption was that my model in both GlowScript and Tracker only accounted for direction and speed in the x-axis, and we assumed in our GlowScript that velocity was constant. While velocity was not constant throughout the entirety of motion of the can, it appeared constant during my segment of the video, most likely because the initial force applied to the can to start it rolling was very close to the resistant forces on the can, such as friction and air resistance. It is impossible to tell just how many frictional forces and other resistant forces were being applied to the can, but it is fair to assume that their combined magnitude is equal to or near that of the initial force applied to the can. Thank you.